Today, computers literally fill our lives. In fact, we almost take them for granted. We use them at work to perform various tasks. We have them at home for various things that we do. We even carry them around on our smartphones. But because they're so familiar to us, sometimes we forget just how complex these devices are. One of the things we want to do in this particular lesson is just sort of take a general look at the whole architecture of a computer, look at the inner workings, and get a better idea about how all those pieces fit together. Let's dive in.
To begin with, you have to realize that where we are with computing today is not how things have always been. These devices were not developed in a vacuum. They actually evolved over time. And I think it helps to understand sort of where we've come from to have a greater appreciation from where we are and where computing is going at this point. Computers of yesteryear, in fact, about the time I was growing up, had to do with mainframe computing. Mainframe computers were very large, they were very cumbersome, and they were very expensive. And typically only high-end businesses had these. For instance, my father worked for General Electric growing up, and they had a very large mainframe in the place where he worked. I actually got to go with him to work, look at the punch cards and all the other sorts of things, which by modern standards are archaic. But IBM inaugurated the mainframe. And this was simply how computing was done for a long time, with dumb terminals, with monochrome screens, and this very large device that by modern standards are very slow. It's ironic that smartphones that we hold in our hand today are more powerful than the computers they used to put men on the moon in 1969. But suffice it to say, the mainframe computer is where computing began. One of the things that helps technologies to take off is when they're made less expensive and when they're made more available to the general public. For instance, steel back in U.S. history used to be very expensive to develop. And when technologies became available to make it less expensive to produce, then you had all of the railroad era and the steel production that really built a lot of the U.S. infrastructure in the previous centuries. The same thing happened with personal computing. About 1975, in Popular Mechanics and Popular Science type magazines, the Altair 8800 was actually purported to be a do-it-yourself type of kit. Now, this is not the way computers are built today. It involved circuit boards and soldering irons and all these sorts of things. And I actually remember seeing that. But it was the first attempt to be able to make personal computing, well, personal. Later, IBM introduced its first model of computer. In this case, it was the portable computer, but it had a $10,000 price tag, which even in the 70s was a staggering amount of money, and most people weren't exactly eager to sign on to that. Just a year later, Apple decided that they were going to inaugurate their own type of computer, and it was called the Apple I. You see, it's actually made from a wooden case, and it was actually offered at $666.66. They just said that they sort of randomly took that as the price. As we went on a little bit into the future, IBM decided to try the personal computer again. This time they made it with off-the-shelf parts, and they wanted to make it much more affordable, so the price tag was not quite so egregious as before. They started calling this codename Acorn, and it was the precursor, the IBM personal computer that later hit the market. And you actually see it represented here. Not very sophisticated, very large drive bays. I actually came across one of these at a garage sale a few years ago. But in '81, they released this computer and they just called it the IBM PC. And to be honest, IBM dominated the landscape for computing for a number of years. Now that you've seen a little about the background of computing and how IBM essentially introduced the game changer, the personal computer, now we can actually start looking at the components that actually comprise a computer. Students of anatomy will tell you, particularly in healthcare sciences, that understanding the functions and the various parts of the human anatomy are essential, as well as how those parts interrelate. So we want to actually talk about the anatomy of a personal computer, how its different constituent parts are constructed, and how they operate together. The actual definition for anatomy by Merriam-Webster Dictionary is actually a separating or dividing into parts for detailed examination. And let's do that now. There are many different parts that comprise a personal computer. We certainly want to be able to take the different sections that involve the system and actually take a closer examination. First, there's the computer case. This is actually the box, if you will, that actually holds all the parts together. Actually allows them to be able to be fixed to some sort of surface so that they won't shift around. There's been a lot of evolution of the types of cases and the size of cases. They used to be quite large. Now they've actually gotten very miniaturized in a lot of ways. But in terms of desktop or laptop personal computing, there's always some sort of case in which the different components are housed and protected. Next, you have the motherboard. This is essentially the heart of the system. It's a very detailed set of circuits and other components that plug into this particular component. And we'll actually explore that more later, but the motherboard actually goes inside the case. Next, you have the CPU, or Central Processing Unit. This is essentially the brain of the computer. It plugs into an assembly on the motherboard where you actually see that fan, and it actually allows all the processing to take place, hence the term Central Processing Unit. You can see it plugs in just like we discussed. Then you have memory. Memory actually plugs into other slots on the motherboard. It's essentially the short-term memory. There's longer-term memory we'll talk about later, but this actually allows for calculations and all sorts of other things that take place within this environment. And then you have longer-term memory, or disks. All of these components work together inside the case to be able to create the environment of personal computing. Each has a role, each has a set of jobs, and each have a specific function that they do to make the system work as a whole. And then you also have adapter cards, which actually add additional functionality. Now, simply enough, we're actually going to step through the different parts of this in separate lessons, but this gives you an idea of the overall architecture of a computing system. Now let's talk about external components. What we looked at just a moment ago was what takes place within that case. But really, the computer wouldn't be all that useful if it didn't have a way to be able to connect to the outside world, either to receive information or to send information. One of the elements that we're all familiar with most computers is a display or monitor. In a laptop, it's actually built into part of the case. But in typical desktop systems, it's attached by an external cable, and it has its own power source. And again, these have evolved substantially over the years, from the sort of very crude, very large green screen type of environment to now multimedia, multicolor displays, and all those sorts of things. So displays. You also have the keyboard, which allows for manual input by the end user. Obviously, a lot of different types of form factors. You have ergonomic keyboards, you have standard keyboards. There was even an attempt for a while to create a keyboard that you could actually type faster on. It was called the Dvorak keyboard, whereas the traditional keyboard is sometimes called a QWERTY keyboard. And the reason why the letters are arranged the way that they are is when mechanical typewriters were invented, they would jam if the person tried to type too quickly. So there have been attempts to change the letter arrangement, but it just doesn't seem to have caught on. And you have the mouse, which actually allows for point-and-click configuration within the system, especially in a Windows environment. It actually allows all sorts of user interaction. So now if we actually put all of these parts together, you can get an idea of how the system functions and sets up. We talked about the external components, the monitor, the keyboard, and the mouse. And then we talked about the case. So interaction takes place between the keyboard, mouse, and the case through special ports that we'll look at later, so that different manipulation of data and selection of menus and so forth can actually take place. And then the monitor actually displays things that are going on, processes and so forth. For instance, in the Windows operating system, you would use the mouse to point and click, and you would actually be able to see what's happening on the monitor. So all these pieces fit together, the internal and external components, into a fully functional environment that we're actually going to take a much closer look at, piece by piece, in the coming lessons.
We're actually at the point now where we want to introduce our first demo. One of the things that's distinctive about train signal training is that we believe hands-on is the gateway to learning. Obviously, there's things that you can hear, things that you can read and see, but reinforcing those takes place through hands-on practice. So what we're going to do is we're actually going to be building a personal computer throughout this course. As you see right here, we have an empty computer case. We're actually going to be adding components to this piece by piece in a progressive fashion throughout the course. When we're finished, we'll actually have a fully assembled system that's fit for production use. So as we go through this, keep in mind it's progressive. The lessons are progressive, and the way we'll be constructing this will be progressive. And it'll give you a great background and reinforce the concepts that you're learning for the A+ certification.
So let's just go over a couple of important terms you want to remember. First, there's the motherboard. Again, this is the primary circuit board of a computer system, which holds many critical system components and provides connectors to other peripheral, another word for external, devices. Memory. Memory is a computer component that is used to retain copies of digital data for some temporary period of time. You can think of it as the computer's short-term memory. Storage device, for instance disks, a non-volatile computer component, which means that it doesn't have to have power to retain the data, that is used to retain copies of digital data for some period of time. Longer term memory in the human brain is similar to this. And then you have an input device. This is a computer component that facilitates the entering of information or instructions into a computer system.
And there you have it, a closer look at the interior of a personal computer, the architecture, how the components fit together, and how they accomplish what they do. I really appreciate you listening in this particular lesson. There's a lot more to come.